Okay, so I'm going to mute myself and I'm going to play that video, but just be ready for me to kind of skip ahead a little bit, okay? Because a lot of it should just be the same stuff from last week, but I want to make sure that we don't skip anything that's a little bit new or a little bit different, okay?
Welcome to a lesson on a D. It would be congruent to triangle MNO because vertex A corresponds to vertex M, vertex B corresponds to vertex N, and vertex C corresponds to vertex O. When referring to corresponding parts of congruent triangles, it is called corresponding parts of congruent triangles are congruent, or CPC-TC. Now remember from the previous video there are 4 postulates that can be used to verify two triangles' congruence. Here we're given a sketch and we determine if the triangles are congruent, and if they are, give the reason and then state a congruence statement. So notice that we're given that segment AB is congruent to segment DE, and they're also parallel. So if these two segments are parallel, notice that BD and AE would be transversals. And therefore we know that the alternate interior angles would have to be congruent. So angle A is congruent to angle E, and angle B is congruent to angle D. So looking at the information that we have, notice we have angle side angle and angle side angle in both of these triangles.
Okay, so a quick few little notes here. Okay, remember that when you have that little, they drew those arrows on the side of those side links that are congruent. They put a little single mark and that kind of little arrow type looking thing. That arrow shows that they're parallel, right? And so you have a few different options here for your angles. Particularly, you have right, that interior angle and that interior angle. They're on the opposite sides, alternate interior angles. Those are congruent. Same thing, the alternate interior angles from this one, this left side and this right side of those parallel lines, right? The line that cuts parallel lines transversal, those are congruent. Likewise, this right here, the vertical angles are always congruent as well. So a lot of things you could do here, but that's the main part of it. Okay, is to see the angle side angle. All right, let's jump a little bit ahead. Oh yeah, also they made note, remember, about it's extremely important how you write your congruent statement. Your vertices must match up. So whatever angles are the same, those vertex points, right, need to be in the same order. So right now I see angle A, how it's that one is congruent to angle E. However you write your triangle congruent statement, if A is the first letter on one triangle, E should be the first letter on the second triangle, or else it doesn't work. And likewise, if B is the second letter you write, if it's ABC, you should do EDC, because A matches with E, B will match with D, and that forces angle C on this side, that vertex point, to be also the same on this triangle as well. So ABC, I would say EDC is probably how he's going to write it.
And therefore, by angle side angle, triangle ABC would be congruent to the triangle on the right. And again, we need to make sure we list these vertices in the corresponding order. So notice that angle A corresponds to angle E, so vertex A corresponds to vertex E. Angle B corresponds to angle D, so vertex B corresponds to vertex D, and vertex C corresponds to itself. Let's take a look at another one. Same question, different information. Here we're given that AB is congruent to DE. Let's go ahead and mark that. And we're also given that C is the midpoint of segment AE and segment DB. Well, here's segment AE, so if C is the midpoint, AC is congruent to CE. And if C is the midpoint of segment BD, then BC would be congruent to CD.
So that's going way back. Remember last semester we talked about midpoints, okay? kind of by definition, right? The middle of something splits it into two equal parts. So if you've got, let's say, a rope that's 10 feet long, you cut that in half, you find the middle point, right? Half of 10 is 5, so one side's 5, one side's 5. That's pretty much what they're talking about here. If it says you've got a line segment and a letter, right, a vertex point happens to be the midpoint, that forces each side to be equal in length, okay? So we call that congruent in this case because it's equal in length, but also it's the same shape. They're both line segments, so they're equal in shape and they're equal in length. Because whatever the length is, you cut it in half, you now have two equal sizes. Okay, that's what they mean by the midpoints both being for both line segments. The midpoint cutting those into equal pieces. Even if it looks like it, you need to confirm it by at least the given information they tell you. You don't usually want to assume unless they tell you or they mark it specifically, okay?
So by side, 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 these two triangles are congruent. So we have triangle, let's say ABC. And again, let's make sure that we list the other triangle. We have angle B formed by the two sides with 1 hash mark and 3 hash marks. So same question, different diagram. Notice the only information we're given here is segment AB is congruent to segment BC, and segment AE is congruent to segment CD. Now these two intersecting segments do form vertical angles, so we could conclude that angle ABE is congruent to angle CBD, but notice we have side-side angle. Side-side angle, or angle side-side, does not fit one of the four postulates, and therefore we cannot conclude that these are congruent triangles.
So once again, he is not saying that they are not congruent. We don't know, but we don't have enough evidence. They didn't label enough stuff, or they didn't give us information, or we just can't tell yet. Okay, what that says, right? The side angle or the angle side, however you see it. They say that there's different options with that. You can actually have different kind of like triangles with that, where there's like a lot of ways to prove that it's just not enough information. But just so you know, for right now, it's either going to be side, side angle, side angle, or angle side. Okay, it's got to be one of those four. If it's not one of those four, which is pretty much leaves three angles, okay, which three angles can look the same, but they might be different sizes because you don't know the side length. And then this whole idea of a side angle, it kind of creates this weird either obtuse or acute angle thing, to kind of depending on how the rest of the angles line up. So side angle and something like that, remember, you're trying to prove that they're congruent. So if you don't have enough information, you simply say you don't have enough information, or I think on the answer choice is just, I think you just say they're not congruent or something like that, or you don't have, or that you can't say they're congruent. I believe on the multiple choice for your assignment, you just say not congruent. I think that should be one of the options. Okay.
So by the given information, we cannot conclude that these are congruent triangles. Let's go ahead and take a look at one more example. Notice we're given two pair of congruent sides, and then both triangles share side BD, and of course it's congruent to itself. So by side, these two triangles would be congruent. So we'll say triangle ABD be congruent to triangle A corresponds to C, of course B corresponds to itself, and D corresponds to itself. And we're going to stop here for this video. I hope you found these examples helpful.
So I thought it was going to do, for some reason, I watched it and I thought it was going over something that is presented in the practice. I'm going to go ahead and kind of like just zoom to the practice real quick because I know near the end there is some stuff you guys need that hasn't been taught to you yet. So we're going to go through that, and then I'll give you guys some notes to copy down, and then I'll release you guys to get the work done today. Okay. So let me go ahead, and this is my student view. So we're here. Cool. I am going to share with you guys topic D3. So maybe you've already started it. That's cool. But I'm going to go ahead and this one you guys should be able to do no problem. You should be okay with this one. You guys should be okay with that one. That one. That one. That one. Oh, and as a reminder, when you guys see like the little square, the little right angle symbol, okay, that's showing us 90 degrees. So if you have a square in this and a square in this, they're just showing you that they're both 90 degrees. So that means they're the same also. They don't have to draw the little half circle thing, right? The little arc, little angle measurement thing with the little bar through it. They just show you a little box, and that box is showing that's 90 degrees in that corner. Okay, that's a perfect little right angle. So let's go ahead and jump to number 7. Okay. And you see it's got transitive, reflective, and symmetric. So let's talk about those 3 properties. Okay. Let's see if I can do this. I can, and let's do this. Okay. And let's put this out for a moment. Okay. So let's stop presenting that, and let's start presenting these. All right. So we are here, and it says complete the congruent statement and name the property. And we have 3 triangles, and it says AC is congruent to DF. So from A to C, it says D to F and GI. D to F is equal to GI. AC is congruent to which one? So it's you got to click one of these buttons, okay, and use this and select one of the properties. So transitive, reflective, or symmetric. So the one that's really important for this one, I believe there's kind of 2 that we need here. We're just going to kind of look at, and that is the transitive property and reflective property. Let's take a look at first at transitive property. Okay, so transitive property. So this is going to be just a continuation on this, okay? Proving triangles are congruent. So this is kind of like going to be page 2. But if you haven't done anything, you can just kind of call this proving triangles are congruent. Kind of just continued, okay? Proving. Okay. So I'm going to put CONT for continued, okay? And this isn't necessarily always used with proving triangle congruence. This can be used in other areas of geometry as well. And that is this right here, okay? Transitive property. All right, I'll just kind of put it in a box right now. So transitive property, by definition, and the property of congruence, okay, is each half is the same but backwards of its other half. Transitive property of congruence. Transitive property of congruence is if 2 shapes are congruent to a third, they are also congruent to each other. So we'll go ahead and write out that statement. If 2 shapes are congruent to a third, okay, they are also congruent to each other. So how does that look like? That looks like this. If I say something like, I'll just go ahead and say this. If I say A equals B and B equals C, then A equals C. Okay, so what do you notice? You have A equal to B, and then also B is equal to C. That says two shapes are congruent to a third. Okay, so you have A, B, and C. If A and B are the same and B and C are the same, that just forces that A and C have to be the same. One of my favorite examples to use is if you know, let's say Anthony is the same height as Brian, and Brian is the same height as, let's say, Carlos. That means that Anthony and Carlos are the same height as well. Okay, that's kind of how I like to kind of see it and use examples of people's height, because if you know if two people are the same height and one of those people is same as someone else, that means that other person also is same as the other person. It's kind of just, you got three things and they're all kind of mixed up. So what you're going to see is stuff like that when you have a problem like this that says AC is congruent to DF. Okay, so I'm going to go ahead and I'm going to copy that down as a further example. So I'm going to make three triangles that all look the same. And let's take a look at the part and piece that they're saying here. Okay, you got three triangles and they're showing that they're all congruent. It's ABC, DEF, and what's important is actually how you write the statements though too. It's not just knowing it, but it's also being able to communicate it to somebody else. And we do that by writing it out. All right. So what do we have? We have on the left side a single mark. On the top side, a double mark. Whoops. And the bottom is the triple mark. So right away, we know side, 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 but we're going to complete it by drawing out the angles as well. So it appears to be, here is a single mark. The top is the double mark. And that top, or the right side then would be the triple mark. Okay. So it says AC is congruent to DF. So let me take a look at it right now. It says AC is congruent to DF. So I'm assuming GI is going to be the next statement. So DF is congruent to GI. Yep. So they want you to fill in this statement. Whoops, did I really put a little squiggle mark above DF? I did. That's super weird. There's no reason to do that. Okay, so lastly, that means that if I cut out DF, okay, if I basically pretend that this piece doesn't exist, right? That means that AC would be congruent to GE. A is congruent to B, B is congruent to C. That means A and C, the first and the third, have to be congruent also. Why is that? Because of transitive property. Whoops, that means similar. What is going on today? I don't know. So the way I see it, once again, is you have three parts. This is congruent to this. If I cut out the middleman, that means the first and the last thing are the same also. Okay, so I'm looking for GI. That would be this letter right here. Select an answer. Is it transitive, reflective, or symmetric? We're going to call that transitive. Cool. So similar question. It's actually the same question. So it's a good chance this actually be the same question you see. So if you're paying attention, that should be a free one for you. Okay. All right. So here's one that's different. Okay. And this is going to be what's called the reflexive property. Okay. So if you look at the reflexive property, look, it's right there. Bam. Okay. So what does that look like? Whoops. That is the reflexive property of congruence states that any shape is congruent to itself. Okay. So let's go ahead and let's call this the reflexive property. All right. Whoops, and my pencil just. All right. Okay, so reflexive property says any shape is congruent to itself. Which sounds dumb, right? It just sounds like, of course it is, okay? But that's, they had to give a name to something. And so when you see something like this, where you see basically, you could see it two ways. Either two triangles, almost like they're glued together, like they're stuck together, or you see it this way, where it's like one triangle with a line down the middle. Okay, however you see it, it's like you're both right. Like however you see it, you're right. Okay, there's no like one wrong way to. There's no like right or wrong way to see this. Okay, but let's go ahead and draw it out the best we can. Hold on. Looks to be about there. Okay, so it looks sort of like this, right? The reflex property or reflexive property. It's reflexive, isn't it? Oh my gosh. All right, reflexive property. Let's label this out. We got A, B, C, and D. So how do they label it? Those sides are the same. The bottom sides are the same. And then they tell you there's a right angle here. They tell you that this is the same as this. And they're telling you the top. Whoops. So double. Okay, so double, double. All right. So what do we have? We've got a side angle side. We also have angle side angle. So there's a lot of ways we could prove this, right? They're the same. But there's also this line in the middle, that BD is congruent to BD. Okay, you see how there's one side that's shared between the two triangles here? So we could say that BD is the same and congruent to itself. Whoops. So I can say that BD is congruent to BD, which sounds kind of silly, but it's not transitive, it's not symmetric, it's called reflexive. Okay? All right. So let's take a look at the next one. DC is congruent to what? Okay, so I'm thinking right now it might be the reflexive or the symmetric. Let's take a look at the symmetric and let's see if that is going to be what happens here. Okay, symmetric property states that if one figure is congruent to another, then the second figure is also congruent to the first. So if Jane's height is equal to Dave's height, that also means that Dave's height is equal to Jane's height. So I believe what this is trying to say, if we take a look at it, okay, is that you can just basically means you can write it backwards. Okay, so if AB is congruent to BC, then BC is congruent to AB. Okay, so reflexive is where it's equal to itself. Symmetric is where you just write it in opposite orders. Okay, so let's jot that one down real quick. I think that one should be pretty easy. We can just fill it in here at the bottom. Now, last time I didn't put a straight line across. I'm going to try to clean that up a little bit on this one. All right. So last one, and let's see if it even makes sense for this one, because it might not. Okay, that is the symmetric property, right? So if you see this, It's the whole idea that if A equals B, then B equals A. So there's not a third piece involved, okay? That's how it's different than transitive. And how is it different than reflexive? Reflexive is where you have the same thing equal to itself. So this has two pieces involved versus one or three. So it's just the two. And you just write them in opposite order, okay? So instead of being A and B, it's B and A, all right? So it's, what was the way? Oh, yeah, the little budgies. So we would say that if one figure is congruent to another, then the second figure is also congruent to the first. So this may or may not come out on this problem. Maybe it's another problem. Maybe it's a similar one you'll see later. Okay, but let's take a look at what it would say. So if we said something like AB is congruent to, let's say, CD, we could say that CD is congruent to AB. Okay, that's kind of the statements you'll see. Okay, where you'll see something congruent to something else, but then that says that that same thing is also congruent back to itself. Okay, it's symmetry. Symmetry means two things are symmetrical, that they're the same. So how's that different than reflexive? Okay, reflexive is where this one thing is equal to itself. And the transitive property says if the first thing is equal to the second thing and the second thing is equal to the third thing, then the first thing is equal to the third thing also. Okay, so there's three things involved with transitive. There's only one thing involved with reflexive, but symmetry, or the symmetric property, has two things. Okay. All right. Once again, if I move a little too fast, you may review this video later. I'll post a picture of this as well. Okay, all onto your Canvas notes. Okay. All right. So complete the congruent statement and name the property. DC is congruent to DC or CD, right? That's what I'm thinking. If we're not quite sure, let's take a look at drawing this out. And let's make sure that we are doing it correctly. So one strategy I highly recommend is this. If you're not quite sure what it is, just draw it out. Okay. What I mean by draw it out is I'm going to draw two separate triangles. So I'm going to draw two separate triangles and try to label them as best and clearly as I can. Okay. So we have, it looks something maybe like this. And then that one looks something like the opposite. I'm actually going to separate them so that we can clearly see, hopefully, what's happening. Okay. So we have two triangles that look something like this. And I just kind of pushed them away from each other. I see in this one here, it's got the little double angle, and that's angle A, or vertex point A. And over here is vertex point B. Once again, it's got the little double angle there. Now we've got to determine, well, I know that's D and that's C. That makes this D and that's C. So it appears that this is the angle and this is the angle. So it's a little difficult to see on the other one. Okay. So when they say something like DC, right, I see it. Now, oh, I would make a little mark here that says that this is obviously going to be the same as that. So it's like angle, angle, side, right? Angle, angle, side somehow. But it looks like, right, they're talking about this piece. Now I'm thinking right now from D to C, that's going in this direction towards the shared or the congruent angle. So I'm thinking, okay, they probably want us to write it like that, C to D. You see how it goes towards that little small angle here, and that's going towards that little small angle there. I'm thinking that's how they want us to see this. So I'm going to look for CD. I see bar CD. Perfect. So when they say bar, parentheses, CD, that's what they mean, the little bar on top. Okay. Now, how many different sides do I have? DC and CD are the same side length, right? So I'm assuming it's going to be the reflexive property, because remember the reflexive property just dealt with one side. The symmetric property was 2 and the transitive was 3. So I'm assuming now, just by the fact that it's only one piece, that it's kind of forcing us to make the prediction that's reflexive property. Let's take a look. Cool. Awesome. Okay. Let's take a look at the next question. And now we have 3 pieces here. I see AE, ED, ED, CD, AE. Now, I don't know the answer yet, but I'm assuming since it's 3 things, it's probably going to be transitive property. Okay, so let's take a look at these statements. I've got a pretty cool looking shape. Now that shape, oh my gosh, that is funky looking. Now, but there's 3 right angles, it looks like. So let's draw that out. Where is a right? There's a right triangle. Let's do a bigger one. So this one is going to look, let's say, something like this. Looks like they did. Where did it go? Is that this one? Okay. And then it appears they did a number here. Okay. Cool. So it's a right angle here, which assumes a right angle there as well. I've got a little right angle there. We got those 3 pieces the same. And they say those angles are the same. So I'm thinking angle, side, angle, angle. That'll be a right angle too. Angle, side, angle, angle. Sorry, angle, angle, side, angle, angle, side, angle, angle, side. And then you have these shared pieces as well. Awesome. Okay. So they're telling us AE is congruent to ED. So we have AB. Sorry, let me draw that out as well. AB, CDE, CDE. They're telling us AE is congruent to ED. And once again, we're making the assumption. Sorry, let me move over. We're making the assumption, since we have 3 pieces, that it's going to be a transitive property. So AE is congruent, they're telling us, to ED, AE to ED, and then ED to DC. And that's then going to be congruent to what? They say AE. So I'm assuming now that they want us to cut out the middle part. If AE is congruent to ED and ED is congruent to DC, that means that AE, taking up the middle, is equal to DC. And that is, by definition, the transitive property. So I'm looking now for DC. And DC is right there. Cool. Bar DC. So submit question. There we go. Okay. So I didn't answer the other ones. That's all the information, the same information from last week. All right. So that is it for today. I'm going to stop the video. If you guys need to review it, I will be posting it today.